We will discuss NEET questions. Okay. So this is the first question in the optics, right? So an achromatic prism is made of crown glass prism, AC is equal 19, flint glass prism 6 degree. So mu values are given. Resultant deviation for red colored ray wave. So if you see for first case, what is the deviation? We know deviation is given by mu minus 1 into A, correct? So it will be, for first case, it will be 1.5 minus 1, that is 0.5. 0.5 into 19, which is 19 by 2, which is 9.5. So this is for first part. The second part, if you see, again d is equal to mu minus 1 into A, which is 1.66 minus 1. 1.66 is 5 by 3 if you think, right? So 5 by 3 minus 1 into A is 6. 5 by 3 minus 1 is 5 minus 3, 2 by 3 into 6. That is the 4. So the resultant deviation will be this plus this, which is 10.5. Then next question is is 107. So a telescope has an objective of focal length 100 centimeter and an eyepiece of focal length 5 centimeter. What is the magnifying power of the telescope? And the final image is formed at least distance of distant vision. See, for telescope, we have seen if image is formed at infinity, final image, m is equal to f by fe. If it is formed at near point, it is m is equal to f by fe into 1 plus fe by d. As you can note down, if it is formed at near point. You just substitute the values now. It is 100 by 5 into 1 plus 5 by 25. 1 by 5 is 6 by 5. That is 25, 25, 4, 4 into 6, 25. Then compound 108. The compound microscope has an eyepiece of focal length 10 and objective 4. This is Fe, this is Fo. Calculate the magnification if an object is kept at a distance of 5 centimeter from the objective so that the final image is formed at near point. So magnification is magnification due to objective and eyepiece. From eyepiece it is a microscope, so it is 1 plus d by f if the image is formed at near point. And for objective it will be v by u, lens. They are given u, they are given f for objective. You find v for that, 1 by v minus 1 by u. So for objective it is 1 by 4, 1 by v minus 1 by u is minus 5, so plus 5. So 1 by v is equal to 1 by 4 minus 1 by 5, 5 minus 4, 1 by 20. So v will get as 20. So this becomes 20 by 5 into 1 plus d is 25 by f by f. F is 10. Okay, d they have given as 20. If nothing is given, you can take 25. This becomes 2, 2 plus 1, 3. So 5 1 5, 4 is 4, 3 is 12. And next problem. Microscope is focused on a mark on a piece of paper, and then a slab of glass of thickness 3 centimeter and refracting index is placed over the mark. how should the microscope be moved to get the mark in focus? So this is the slab, suppose. So and is kept here. When microscope was there, and without this glass slab, it was able to focus somewhere. But now with the glass slab, because U changes, because the ray which comes to the microscope will be like denser to rarer away from the normal. So it will be as if the object for microscope is here. So U changes. If U changes, F is same. So V changes, but V has to be same for it to focus at a point. So to keep V constant, you have to keep U also constant. So to keep U constant, you have to take it up or down accordingly. See here, if you see the object is coming towards the lens, so lens should go. The microscope should go. It should be raised up, right? So it should be raised up only, but not down. So among these two, we have to see which is the answer. So by how much this gets raised, by that much amount, this has to be raised, right? So we see this is apparent depth, this is real depth. So real depth minus apparent depth is your answer. So real depth minus apparent depth, and apparent depth is real depth by mu. So real depth is 3 minus 3 by mu is 1.5. So this is 2, 3 minus 2 is 1. So it has to be raised by 1 centimeter upwards. Then so what causes chromatic aberration? So chromatic aberration is some distortion in color. So why this happens is because of variation of focal length of lens with color. If this is a lens, this is used to get image of some object. For different colors, the lambda changes. If lambda changes, focal length changes. Sorry, if lambda changes, refractive index changes actually. If refractive index changes, then for same eye, different colors will have different R. So R will be different. So there will be some amount of chromatic aberration. White light comes, but here suppose image of some object has come, but at the borders there will be some uh, problems with the color. They will look as if they are split. Right? It is due to variation of focal length of lens with color. Then we have assertion and reason. Statement 1, okay, see option A means statement 1 is true, 2 is true, 2 is correct explanation for 1. And B means statement 1 is true, 2 is also true, but statement 2 is not correct explanation of 1. And C is 1 is true, 2 is false. And fourth option or D option is 1 is false, 2 is true. So we will see it easy only. The images formed by TIR are much brighter than those formed by mirror lenses. There is no loss of intensity in TIR. Yeah, this is correct. Because in TIR, no refraction happens. So whole of the light will come to TIR only, reflected light only. So it has a maximum intensity. So that's why it is more brighter, most brighter compared to others. Because in other, there is a chance of more absorption and some amount of transmission also into the other medium. TIR not. So there is no loss of intensity in TIR. So both are correct, and this is correct explanation for that. Correct. Then dissolving power of an electron microscope is higher than that of an optical microscope. If you see, dissolving power is d by 1.22 lambda. D is constant. So for electron, if you see lambda is less, so dissolving power will be more. The second is wrong. The length of electron is more less actually. That's why it gives more resolution power. So it is higher. So this is correct. So this is option. This is correct. This is wrong. statement is only wrong. Then dispersion of light occurs because velocity of light in a material depends upon its color. Yeah, this is correct. Because velocity depends on color. Actually, velocity depends on wavelength. Wavelength depends on color. So indirectly, velocity depends on color. So if velocity depends on color, then refractive index, which is C by V, this also depends on color. If refractive index depends on color, then sin I by sin R is equal to n, right? For same I, for different n's, there will be different colors, there will be different R. So they will get bent by different amount. Because they will get bent by different amount, there is splitting of color. That is called dispersion. Right? So this is correct. The dispersive power depends only upon the material of the prism, not upon the refracting angle of the prism. Yeah, correct. Whatever refracting angle you take, dispersion is not dependent on that. So both are mm, so both are true actually, but this is not correct explanation for this. Correct. 115. The angle of the base of prism are equal, then in position of minimum deviation, the refracted ray will pass parallel to the prism. Yeah, this is correct, but it is not compulsory that this should be the case. Angles of the base prism should be equal. Not the case. If it is there, it's good. So then in the case of minimum deviation, angle of incidence is equal to angle of emergence. This is also correct. So both are correct actually, but this is not correct explanation for this. If this would have been not there, maybe option A will come. We'll go for next question. To 115 we have 116. In a glass slab, a double convex air bubble is formed. This is a glass slab. The double convex is formed. This air bubble behaves like a converging lens. Actually, it will become like a diverging gas, a diverging lens because mu mu of the surrounding is more. Mu2 and mu1. Mu2 is surroundings. Mu2 is greater here compared to mu1. In general, mu2 will be less. mu1 is surroundings. Mu2 is the material. In general, mu2 is greater than mu1 actually, but here mu2 is less than mu1. So F, which was supposed to be positive, becomes negative. It acts like diverging lens, not converging lens. Refractive index of air is more than refractive index of glass. This is also wrong. Refractive index of air is not more, it's less. 17 problem. We cannot produce a real image by plane or convex mirrors under any circumstance. Now, this is not the case because if object is virtual, an image will be real. Image is found by the actual meeting of rays. This is wrong. Focal length of convex mirror, okay, mirror is always taken positive. Yeah, correct. According to sign convention. This is correct. This is wrong. Then we have 118. A double convex lens, mu is equal to 1.5, has focal length 10, and the lens immersed in water. Focal length is 40. So if you use this formula, 1 by f is equal to mu2 1 minus 1. Here 1 is the surrounding medium, and 2 1 by r 1 minus 1 by r. So how we can do? Mu is 1.5, 1.5 by 4 by 3, 3 by 2 by 4 by 3 is 8 by 9, 8 by 9, no, 3 by 2 by 4 by 3, 9 by 8, 9 by 8 minus 1 into So initial case if you see 1 by 10 is equal to 1 by f is equal to 3 by 2 minus 1, that is 1 into double convex length, so 2 by r. So 1.5 minus 1 is 1 by 2. So 2 cancels, f becomes equal to r, which is equal to 10. So here also you can see you will get 2 by r. This 2 by 2 by 10. 2 by r. This becomes 9 by 8 minus 1 is 1 by 8 into 2 by 10. 1 by 4 is equal to 1 by 40. So f becomes 40, right? Which is they are given correct 40 centimeters. So this is found using this formula, correct? This is mu2 1 minus 1 only. This is mu2, this is mu1, that is medium. So both are correct and this is correct explanation for this. Right? So we'll end it here. If you have any doubts, you can ask. So we'll end it here. Thank you very much for joining.